Hello and welcome to my presentation. My name is Benjamin Anderson, and today I'm going to be talking about Git and the command line interface for Git. What we'll cover during this presentation are version control systems, Git itself, GitHub, the command line interface for Git, the basic flow of using Git, some common commands, branching and merging. We're going to talk briefly about GitHub for desktop, and some Git resources, and then we'll also do a short demonstration of using Git. Version control systems have been around since before computers. They basically are just systems in place to manage changes to an existing system. So for computer software, that's really useful because then multiple people can work on the same software without creating problems when they try to merge those changes. There are two main types or forms of version control systems. There are centralized control systems and distributed control systems. Centralized means that there's one server, one computer hosting the source code, and only computers or people within that network can access it. Distributed means basically that it's hosted on the internet, and therefore anybody with access can find that software and make changes to it. Obviously, distributed is more widely used today. It's more useful within the computer software engineering world today. And finally, just to mention, you might see the term SCM when talking about version control systems, and that just simply means source control management. Git is a distributed version control system. It was created by Linus Torvalds in 2005 and has been maintained by Junio Hamano ever since. And a fun fact, Linus is known for naming projects after himself. He was also the same person that originally created Linux, and you can see how that's only one letter different from his name. And Git is a British English slang term for an unpleasant person, basically, and he always joked that he named that after himself. GitHub is an internet hosting service for Git. It was launched in 2008, acquired by Microsoft in 2018, and it includes additional features and commands for Git. It builds upon it. And most notably, it includes a better form of pull requests and merging to remote repositories. It used to be more complicated. The command line interface allows users to issue the Git commands. It always comes with Git when you install it. It is the only place that you can run all Git commands. Most GUIs only implement a subset of Git's functionality. And also, just to note, it's a really good idea to learn how to use Git on the command line interface before branching out to GUIs. It's really helpful to learn what's going on under the hood when you issue those commands before you start, putting a GUI over that. The basic flow of using Git is to modify. You make changes to the local repository on your machine. You then stage those changes, which means that you tell Git, these are the files with changes that I want to add, and these are the files that I don't want to add. You then commit those files that you've added to the staging area. And once you do that, as far as your local machine is concerned, the local repository has been updated and it's completely done. But then what you can then do is push that local repository commit to the remote repository online, and then other people can have access to those changes from the remote repository. And just a quick note here, it's always a good idea to pull changes from the remote repository before you make any changes to your local repository. This will avoid many headaches and merge errors. Some common commands and just a brief description of what they do. These are git init. This one will initialize a repository on your local machine. Git clone with a URL will clone a repository that already exists on the internet. It'll clone what's there, and it will create a local repository from that remote repository. Git add with the associated file names will add specific files to the staging area to be ready to be committed. And just a little note here, if you type git add space period, that will add all files that have been changed to the staging area rather than having to type them one by one. Git status will return all changes that have been made to your local repository, and Git will note which ones have been staged and which ones have not been, so that you know which ones need to be added. Git commit with an appropriate and descriptive message will basically finalize those staged changes on your local repository, and then Git push, like I said before, will push those changes to the remote repository so other people can access them. Git pull will pull from the remote repository. It'll get all changes that others have made there and merge them into your local repository so that you have access to them on your machine. Branching and merging. Branches can be very useful. This is what allows multiple people to be working on the same source code without creating lots of errors. More specifically, it allows one person, they might be working on a specific feature within this software, and this allows them to continually push their changes to the remote repository without pushing it into the branch that everybody else is using. Typically, there is a main or master branch in the source code, and then you can then create branches with new names for specific things that you're working on before you push those changes into the main branch. So then, if you're working on somebody, if you're collaborating on something with somebody, they can have access to that branch as well on their local machine without either of you actually pushing that branch into the main branch of the source code. Some of these common Git commands include git branch by itself. This will return a list of all branches that are on your local repository. Git branch with a branch name will initialize a new branch on your local repository. Git checkout with a branch name will take your machine and all changes that have been made into a branch, a new branch. Or sorry, an existing branch actually. Git merge with a branch name will take that branch that you specified and merge it into the directory or the branch that you're currently in. So it'll merge the two together and all associated changes. Git fetch will access the online repository, and it will bring all branches on the online repository to your local repository on your machine so that you have access to those other branches. Just very quickly, GitHub for Desktop is an example of a GUI for Git. Like I said before, once you have mastered the basics of Git, you understand what's going on under the hood, using a GUI can make things faster and easier, sometimes more intuitive. But again, not until you understand what's going on. If you don't, then it can make things more complicated. This is just a small list of resources for Git, including where to download and install it, a cheat sheet for the commands, the actual reference, and also you can type git help space any Git command, and Git will tell you, the usage for that command, what you can do with it, and what it needs, the syntax, and so forth. We'll now have just a short demonstration. So here I have GitHub open. The easiest way to demonstrate this is to create a repository on GitHub and then clone that repository to your local machine and make changes from there. So for example, we can hit new to make a new repository. We can just give it the test name, and we don't need to change anything else because this is just for testing purposes. So we can create it. You notice that we have a URL to access it. We'll leave this the way it is for now. We'll open up the git bash and the directory that we want to be working in, and you can see in the git bash I've navigated to this directory. You can use the cd command in the git bash to change directory. What we can do now is we can type git clone, then we'll open up some parentheses, we'll come back here, get the URL, Come back, paste it, close the parentheses, and you can see it's warning us that we've cloned into an empty repository. That's fine, that's what we wanted. We know it's empty, and that means it worked. You can see that test is now here. The repository is on my local machine. What we can do then is we can make some changes. We can just quickly open up in Visual Studio or whatever IDE you might want to use. We can add a file. I'll just call it test.py just to make sure there is a file. Now if we go back to Git and we if we change directory into test, you can see that we're there in the directory now, and also that it knows what branch we're on. Here it says main. That means that we're on the main branch. I'm not going to demonstrate using branches, but it's always a good idea to navigate into another branch to make changes and then later merge that into main, but for now we're just going to work in main for the purposes of the demonstration. So now that it recognizes the branch that we're on, we can hit git status, and you can see that it knows that we've made a change, and it also knows that it's untracked. That means that if we commit right now, that change will not be added to the commit. So we need to git add test.py or period to add all changes. And then if we hit git status, you can see it's now green. It says changes to be committed. It's tracked, which means that if we git commit -m with a message, and you should be more descriptive of this when you're working on actual software, but for now we'll just say something like created repo and test.py. We'll say what we're doing. We'll commit it. It's going to say some things we don't understand, but if we hit git status one more time to see what it's doing, you can see there's no longer any changes. There's nothing to commit. As far as the local repository is concerned, we're done. It's been updated. But if we go back to GitHub, you can see nothing's here. It hasn't been added. It still thinks it's empty. That's because we haven't pushed it. So if we come back to Git, we can git push, and that will spit out some more things that looks like garbage. But if we come back here now, you can see that test.py has been added to the remote repository. That's all I'm going to cover here. Obviously, it can get a lot more complicated, but that is the basic workflow of using with Git. I hope that was helpful, and thank you so much for watching.